Now let's do some examples using the fundamental theorem of calculus. Suppose I want to look at the integral from 0 to pi over 4 of secant squared x dx. Now, I know the antiderivative of secant squared is tangent of x, and we're going to evaluate it at 0 and pi over 4. Now, I remember you plug in the numerator, or you plug in the upper limit and subtract the lower limit. So this is tangent of pi over 4 minus tangent of 0. Now the tangent of pi over 4 is 1 minus 0, so this is 1. Now what do you do if you have an absolute value in there? Well, the first thing I want you to do is rewrite the absolute value sign, part of the equation, as a piecewise function. All right? Now, when x is less than 1/2, then the absolute value function is equal to the negative of what's inside. So this is minus 2x minus 1 when x is less than 1/2. When x is greater than or equal to 1/2, this is simply equal to the function itself. So this integral becomes the integral from 0 to 1/2 of minus 2x minus 1 dx plus the integral from 1/2 to 2 of 2x minus 1 dx. And now I can break these up. This is minus 2 times the integral from 0 to 1/2 of x dx. Minus and minus is plus, so it becomes plus the integral from 0 to 1/2 dx plus 2 times the integral from 1/2 to 2 of x dx minus the integral from 1/2 to 2 of dx. Now let me check this because I make algebra mistakes. Minus 2 integral of x plus 0 to 1/2 dx plus 2 integral 1/2 x minus. All right. So this is minus 2 times the integral of x dx is x squared over 2 evaluated at 0 and 1/2 plus this is going to be x evaluated at 0 and 1/2 plus 2x squared over 2 evaluated at 1/2 and 2 minus x evaluated at 1/2 and 2. Let me give myself a little room here. Those are going to cancel. So this first term becomes, the 2's cancel, so it's going to be 1/2 squared minus 0 squared. Now let me switch colors. I'm going to alternate these so that we keep this straight. So, well, that didn't change, did it? Okay, my pen won't let me change color. So we'll do it this way. This part right here becomes 1/2 minus 0. This right here, the 2's cancel. So this is going to be 2 squared minus 1/2 squared. And then this is going to be minus 2 minus 1/2. Now if we do all this, we get our algebra correct, we should get 5/2. Now, what if I wanted to use the fundamental theorem to find an area? Well, that's exactly what we use it for a lot of the times. To find this area, I'm going to find the integral from 0 to 2 of 2x squared minus 3x plus 2 dx. Don't forget your dx. So this becomes, let's see, 2x cubed over 3 minus 3x squared over 2 plus 2x evaluated at 0 and 2. This whole thing is evaluated. So I'm going to factor out 2/3. This is 2 cubed minus 0 cubed minus 3/2 times 2 squared minus 0 squared plus 2 times 2 minus 0. So this becomes, if I add all this up, 10/3.